Hello, everybody. How are you doing today? Good. Let me put this here. I'm a little bit stressed about doing a talk. Doing a talk is not a natural thing for me. I'm going to hold it. I don't think that works. I think it's more stylish. I think content creators do it like that, right? Okay, but why are we here today? Today, I'm going to talk to you about why Ops is a mindset and how site reliability engineering, or SRE, can help teams grow their engineering maturity. My name is Theo. I'm a site reliability engineer, and I work as a consultant for Mpya Digital. So here's what we're going to cover. First, I'm going to give you a quick intro into what site reliability engineering actually is and where it came from. Then, I will explain why reliability is not just a role or a set of tools, and it's not just an operations problem, but really a product problem. We're going to have a look at how the SRE mindset is different from the traditional operations mindset, and I'm going to show you a maturity pyramid that teams typically climb on their reliability journey. After that, I'm going to walk you through some practical practices: code ownership and testing, unified CI/CD, cloud fluency, and a culture where reliability is part of the product. We're going to talk about how reliability is measured, and we will go through a real-life story. And then I'm going to close with the incident lifecycle, the impact reliability can have on business, and a few key takeaways and concrete steps that you can start with right away. But what is exactly site reliability engineering? It originated back in the early 2000s at Google. The good folks at Google, they had a problem. They could not scale their operations fast enough to keep up with their engineering growth. So they asked a simple but rather radical question: what happens if we hire software engineers to run operations? And that's exactly how site reliability engineering was born. The most basic definition is what happens if you ask a software engineer to design operations. Since then, it has grown into a whole discipline. There are two main books out there: Site Reliability Engineering, clever title, and the SRE Workbook. But the point of today is not to memorize any textbook titles. What I want you to take away today is that site reliability engineering is not just a niche role or a set of tools. It's rather a mindset about how we approach reliability. So here's a key idea. Reliability is not just an operations problem. It's rather a product problem. When users are trying to access your product, your application, your website, your service, they don't experience your code, they don't experience your deployments, they don't experience your on-call rotation, but on the other hand, they experience if your product is slow, if it crashes, if it goes down. This is all part of product experience. And when reliability is poor, then people tend to lose trust. They might churn. They might stop recommending your product, which means that reliability directly affects growth. And that's why this cannot be solved by ops alone. Excuse me. Ops cannot scale reliability for a whole company. Reliability has to be designed into the product from the very start and be owned by the teams building it. Now let's try to contrast the traditional operations mindset with the more modern SRE approach. Traditional operations often looks like firefighting. Tickets pile up, teams hand work off, deployments are manual, and the responsibility is siloed. The main measure of success here is the system up and running right now? On the other hand, the SRE mindset is trying to flip all that. Instead of firefighting, we have the focus on prevention. Instead of ticket queues, teams share ownership of services. Deployments are automated and rollbacks are built in. Responsibility is cross-functional. And of course, the goal here is not just uptime, it's reliability as a product experience. And this shift is what makes SRE powerful. It's not about just adding another team to your organization. It's rather about changing the whole mindset of the engineers and how they think about their responsibility for reliability. Teams don't just wake up and they have a reliability culture. It's more or less a journey. It looks like a maturity curve or a pyramid, if you will. At the base of the pyramid, we have ad hoc firefighting. Teams are reactive, always putting out fires. Then on top of that, you have process and monitoring. You start adding some structure to your organization, maybe some dashboards, maybe some alerts. Then the third stage is automation and CI/CD. Deployments become safe and repeatable, and manual work starts disappearing. And then at the top, you have the reliability culture. This is when reliability is not just a process, it's something that the whole team values. It's designed into features, it's measured, and it becomes part of the identity of your engineering organization. Of course, site reliability engineering practices help us climb this pyramid. Now let's start with the foundation, code ownership and testing. There's a very simple principle here. If you build it, you run it. Of course, that doesn't mean that every engineer has to be on call 24/7. But what it does mean is that the teams are accountable for how their code behaves in production. Testing goes beyond unit tests. It's all about resilience. You want to test what happens when your dependencies fail, when load spikes, when the network flakes out. Chaos testing and load testing are not just luxuries. They're part of building reliable systems. Ownership creates accountability, and testing creates confidence. Now, the next piece is deployment. Many organizations have fragmented pipelines. Every team builds and ships code in a different way. Of course, you can understand that this fragmentation is making releases fragile. On the other hand, the SRE mindset is pushing for unified CI/CD. That means standardized pipelines where every deployment goes through the same quality gates. It means fast rollbacks are built in. It means testing and verification are consistent. The result, safer and more frequent releases. The teams ship code faster and without fear because the system itself is created to catch problems early and roll back quickly if things go wrong. Then we have cloud fluency. These days, most systems run in the cloud, but many engineers treat the cloud like a black box. The SRE mindset says every engineer should understand the basics. How scaling works, what fault domains are, how monitoring ties into costs, and how to design for resilience. It's more or less like driving a car. You don't have to be a mechanic in order to drive a car, but you need to know how the brakes or the gears or all the compartments work in order to drive safely. Cloud fluency is part of the modern engineering literacy. Without it, you cannot really build for reliability. Now, one of the most practical ideas in site reliability engineering is how we measure reliability. We have two main concepts here. First, we define what we call service level indicators, or SLIs. And these are the things that users typically experience. That's uptime, that's latency, that's error rates. On top of that, you have service level objectives, or SLOs, which are goals in the form of ideal measurements for SLIs. For example, 99.9% uptime. This is great, but what it actually means is that we can afford to have 43 minutes of downtime. This is a 0.1% per month. And that's where the error budget comes into play. And what it is that it's the slice of unreliability that we can afford, which means that once we've spent the whole budget, then we need to stop shipping new features and we need to focus again on stability. And this is how site reliability engineering balances business goals with reliability goals. It's more or less like a common language between product, engineering, and operations. It might also be worth looking into what not to do. First, the traditional mindset says that reliability sits with ops. Devs ship code, and then ops clean up everything. You can understand that probably this doesn't scale in today's standards. Second, testing only for correctness. Yes, your code might be passing unit tests, but if it breaks under load, it doesn't matter. Your users don't care, it's still broken. Third, staging that doesn't match production. We're going to have a look at what happens when redundancy and replication are not tested until production on the next slide. And finally, hero culture. If your reliability strategy depends on individuals firefighting at 3 a.m., I got news for you. You don't have a strategy. These anti-patterns are what site reliability engineering helps us move away from. Now, let me share a quick story from my own experience. I was building a service for a customer, and for their own reasons, they did not want to enable multi-region support in their staging environment. The main argument was that why should we pay for something in staging when we already have it in production? But as you can guess, that came back to bite us. Redundancy failures and replication issues could not be discovered until we were already in production, which was already too late. And the reason was that simply staging did not mirror the real setup. Eventually, the team agreed that staging should be identical to production. Yes, we accepted that the cost went up a little bit, but the payoff was huge. The number of related incidents dropped dramatically. We were not firefighting as much, and the system became far more predictable. And this is a classic example of reliability as maturity. You spend a little bit upfront to save up a lot of pain later. Now let's talk a little bit about incidents, because this is where site reliability engineering truly shines. Every incident has 4 phases: detection, response, resolution, and learning. Most teams traditionally stop at phase number 3, resolution. They fix the problem and then they move on. But for the site reliability engineering mindset, the most important phase is the learning part. We host blameless postmortems in order to identify systemic issues and work on preventing them from happening again. The key here is that incidents are not just bad. They're great opportunities to grow and get better. And that's exactly how reliability maturity grows over time. Now, let's take a step back and try to connect reliability with business outcomes. Downtime is not just annoying for engineers. It might cost money. It might cause churn. It might affect your reputation in a negative way. For example, if a software as a service company makes $1 million a day, just 0.1% downtime, which is the 43 minutes per month we talked before, can cost up to $1,000 per day. Over a year, that's a big hit. But the flip side is also true. Reliability builds trust. It makes users more confident. It encourages adoption, and it might create a competitive advantage. As you can understand, all of the above is proof that site reliability engineering is not just an engineering maturity practice, it's a business enabler. So, what should you remember from this talk? First, reliability is not just an operations problem. It's more or less a product problem. Second, site reliability engineering is not a role or a set of tools. It's a mindset, a way of engineering that prioritizes reliability as a feature. Third, the practical practices we talked about: code ownership and testing, unified CI/CD, cloud fluency, and culture. All of these are levers that help us climb the maturity pyramid. Fourth, reliability actually delivers business value. And finally, fifth, reliability is everybody's responsibility. Finally, let's try to predict where SRE is going over the next 5 to 10 years. First, hot words, AI and machine learning are changing the landscape of incident management. We're moving towards systems that can detect and even remediate issues automatically. Second, reliability is expanding beyond infrastructure. These days, we're talking about data reliability, machine learning reliability, or even security reliability, applying the same concepts across multiple domains. Third, multi-cloud and edge computing are introducing new complexity. Designing for reliability in these new environments is the next frontier. The bottom line, the ops mindset is spreading. Reliability will be an expectation across all of engineering, not just a niche role and a set of tools. So my challenge to you is this: pick one of the maturity levers that we talked about. It could be any of them. It could be your deployments. It could be your testing. It could be your postmortems. Just choose one of them and try to raise the bar a little bit. But don't try to change everything overnight. Reliability is not something that is bolted on overnight. It's something that is designed in step by step. If you do that, not only you're going to be able to reduce the incidents you're facing, but you will also grow as an engineering organization. Remember, ops is a mindset. Reliability is everybody's job. Thank you. Questions? Yes.
What would you say are the key differences between SRE and DevOps?
Well, that's a very good question. And I think there's a lot of different opinions out there.
Could you repeat the question?
Yes. The question was, what are the differences between site reliability engineering and DevOps?
I saw in your eyes to have this conversation before with someone behind me.
Well, here's the thing. I have my own personal view on things, and some of you might disagree. Thank you.
I agree with you too.
I think the boundaries between the different positions are a little bit vague because I've had the title of site reliability engineer, and I've done stuff that could be a DevOps engineer's responsibility or a platform engineer's responsibility. So I think it's not differences in the sense of duties, it's more or less different approaches. So in my mind, DevOps is more focused on operations, like for example, take CI/CD pipelines as an example, while SRE is also defining a strategy, because if you define SLIs and SLOs, you have specific goals about the reliability of the system or the performance of the system. So I think it's both parts of a bigger umbrella term that should be operations as a whole. Any other question? Thank you.